So exam 1 will cover chapters 1 through 5, and here's a practice exam. So here's the information, the amount of months that nurses have been working at this particular hospital. We'll use the graphing calculator to find the mean and standard deviation. So go to Stat, and then Edit, and type the numbers in the list. So I went ahead and already did that. Once you have that done, go to Stat, move over to Calculate, and it's the one variable statistics. On this version of the calculator, I need to go down to say Calculate. So there we have the mean and the standard deviation. And for standard deviation, we would be using the sample because this is a sample of just 21 people. So X bar is 27.143 and S is 19.528. Next, for the box plot. Well, if you look at this information right here and scroll down, then these are the numbers that we need for the box plot. So it's going to go from 2 to 67. Oops, this is 2 to 67. And then what I like to do is just put a little mark in the middle. If you add 2 and 67 together, that would be 69. Cut it in half, that would be 34 and a half. So I just really lightly, 34.5 goes right here. So that gives me somewhere to then put these other points. So an 11, that would be very close to 2, and then we would have a 22. So an 11 and a 22 would go next. An 11, if this is 2, 11 is pretty close to that, so 11. 22 would be approximately right here. The other number that I need to use is 41.5. And since this is 34, then 41.5 would be approximately over here. So label it, and there we go. So what does it say about the nurses at the hospital? So they range anywhere from working there for 2 up to 67 months. But actually the majority, so this is 3/4 of them. 3/4 of them have worked there for under 4 years, because 48 would be 4 years. So 75% of them have worked there for less than 4 years. Next, find the percentile. So you would just change this to this 41 to a decimal, and then multiply by n. So n, I had it over here, is 21 people. Oops. And so you multiply these. 41% of 21 people, 8.61. So 8.61. So that's saying put the numbers in order, go through them, and find the 8.61 person. Well, there is no such thing, so you have to round this up to the 9th person. And you can even have the calculator put the numbers in order. If you go to Stat and go to the second one, ascending means from smallest to biggest, and then you just have to tell it the list, so put second 1 or the second L1. It's now in order, and now we can easily find the 9th person in the list. 19. So that person has been 9th person, has been working 19 months. Now a frequency table with 4 categories. So first of all, you need to find the range. And, well, we have the numbers for that right here. 67 is the biggest and 2 is the smallest, so you subtract those two. So basically it's a range of 65 months that has to be divided into 4 equal pieces. So that's going to be called the width. 65 divided by 4. 65 divided by 4. 16 and a quarter, but I don't feel like working with decimals, so I'm going to round it up to 17. So I would put right here that it's 16.25, but I'm going to round it up to 17. So now what you do is make a little table. And now we need 4 rows. What we do is start down here with the very smallest, which is the person that's worked there for 2 months. And then use the width. So right here you add 17. And so that would be 19. And then you add 17 again, which would be 36. And you add 17 again, 36 plus 17, it's now 53. And then to fill in the missing numbers, this one has to go from 2 to 18 because this one starts at 19. This one would go to 35. This one would go to 52. And then this one, you could just put the biggest number, which was 67. Now it's just a matter of counting. And again, having them in the list in order will help with that. So go back to Stat and look at the list. I need the numbers 2 through 18. So this is the first one. So 1, 2, 3, 4, 5, 6, 7, 8. No. So that was 8. Next I need 19 through 35. So this is the first one. Second, third, fourth, fifth, sixth. No. So that was the 6th one. And then we start with this and we'll go up to 52. So this is going to be number 1, 2, 3, 4, 4. And now in the 50s up to 67. So 1, 2, 3, and that's the end of the list, 3. Now the other thing is when you finish, remember that the sample size was 21, so you need to make sure that these numbers add up to 21. And I can see they do because a 3 and an 8 would be 11, plus this is 10, so that's 21. So we didn't leave anybody out. Next, would it be unusual? So this is a keyword saying find the z-score. So this is the information given 4 years, but keep in mind that this other information has all been in months. So tried to trick me, but it didn't work. We used 48 months. So it's going to be 48 minus, at the top of the page there's the mean, 27.143 divided by the standard deviation of 19.528. So a 48 minus 27.143 divided by 19.528. 1.068. The magic cutoff is the number 2. If it's above 2, it's unusually high. This is not unusual. It's not above 2. All right, now let's move on to page 2. In your own words, carefully explain what standard deviation tells you about a set of data. So the idea of standard deviation is that it measures how much variation the scores vary about the mean. So you need to give a general explanation as to what it is. After that, you could then add some other information like what it's used for. So for example, if the standard deviation was 0, that means all the scores are the same. Or if a score is 2 standard deviations from the mean, then we consider that unusual. But those last 2 things need to go after you give the general idea, which is you're measuring how much variation the scores have, how much they vary from the mean. Next, here's a keyword, how many. So this means counting. We only had one section on counting. And with counting, you have to decide, does the order matter? So when they rent 3 movies, now this test is actually, this practice test is actually old, because when I made this up, this was the days when people would go to stores and actually rent DVDs. That's what I was thinking about, rent 3 movies. So does the order matter? So as the couple is walking up to the counter with their 3 movies, does the order of those movies matter? No, the order does not matter. If order does not matter, then you use combinations. So out of the 20, they're going to choose 3. And then I'm going to use the calculator for that. So it's going to be out of 20, math, probability, choose 3. So there's 1,140 different combinations possible. Oh, I guess it wasn't that old of a test. President Barack Obama, approval rating is 40. So as soon as you see a percent like that, then it's probably a binomial situation. The p is equal to 0.41. And then suppose that n equals 800 people were chosen. Find the mean and the standard deviation. So the mean in a binomial situation is n times p. So we just need to multiply those 2 numbers. The standard deviation is equal to the square root of n times p times q. And in case you forgot, remember you can use this formula card, which also has these tables on the test. All right, so now let's do the math. So it's going to be n times p is going to be 800 times 0.41. 800 times 0.41. So out of 800 people, we would expect 328 to approve of the job that Barack Obama was doing. And then for this one, it's going to be 800, then the 0.41. And then do you remember how to find Q? It's 1 minus the P. So it's going to be a 0.59. So the square root of 800 times 0.41. Notice that right here, I don't use parentheses because I don't want it to stop the square root. Here I have to put parentheses, but here I don't. Just say times and also times 0.59. So the standard deviation would be 13.911. So with this review, I'm beyond showing you the types of problems and examples that you should be able to do. I'm also showing you how much work you should be showing and how much you should be using the calculator. So there were 5 types of sampling methods way back in chapter 1 or somewhere way at the beginning. So 22 people are chosen from each state in the union. So you basically take the United States, which looks like a rectangle, you divide it into states, so divide it into pieces, and then you choose 22 from each state. So 22 here, 22 here, 22 here. That is called stratified. And these pieces are the strata. So next, this one, students are divided into 10 groups based on their age. So it starts off sort of the same. You divide them into groups, and then 3 of the groups are chosen. That is called the cluster method, because these, when you say it's the group, it's a cluster. So which would have larger standard deviation? I think that I did this one on one of the earlier reviews, but anyway, this group right here would have the larger standard deviation, because you would have 13-year-olds that perhaps have not gone through puberty and are very short, they're 4 foot something. This group would also include 19-year-olds that could be 6 foot something, so there would be more variation in their heights. What do you think about the next one? The weights of people going to Weight Watchers or the general population? Well, the general population is going to have more variation because this has people that are extremely skinny, some 80-pound person, and I didn't say adult. I should have said adult. I was thinking adult. Okay, assume that says adult. Because otherwise you could be a smart aleck and say, well, you could have newborn people, babies that are, 3 minutes old, as well as 400-pound sumo wrestlers. Anyway, if it's adults, it's still this because you would still have people that are very, very skinny, very, very heavy, where with Weight Watchers, they would all not be the same weight, but they would all be much closer in weight. So that would be less variation for the Weight Watchers. And with two-thirds done, excuse me. So before I even start reading this question, I see this, and my mind just goes like this. Before I even started reading it. It's a binomial situation. So Billy Bob works in a drug testing lab. 12% of the tests usually come up positive. So in a recent batch of 14, so that means that n equals 14, none of them came up positive. So find the probability that none. So this is a binomial formula. We're going to be using probability that x, the number of ones that came up positive, is 0. None of them came up. And you could use the binomial formula if you like, or I'm going to use the calculator. And here too, I'm trying to show you, yes, you can use the calculator, but you should write down and show me what you're doing in case the answer is wrong. I at least have an idea of what you're doing. So out of 14 tests, 12% should show up positive, but we're saying 0 of them did. What's the chances of that? So over here under distributions, that's where you find the binomial. So go down, I think it's about the 10th one, the 11th on my calculator. Binomial PDF. Now, depending on the version of calculator you have, if you have an older version, it would just put this on the screen. You type the 14, comma, 0.12, comma, 0, and paren. With these newer operating systems, they want you to put it like this. The n, the p, and the x value of 0. And then paste that onto the home screen. So for the other people, they just finish typing that, then hit enter. So it's a 0.167. And one thing that comes to mind to me is that that is not below 5%, so that is not unusual. Because later on, somebody's probably going to ask me to do some explaining, and I can start my explanation with that. What happened is not unusual. Oh, you know what? I could even do that right now. Should this guy be fired because no test came up positive? No. Because the answer to A is not unusual. When you give explanations in this class, they should be statistically based. Please don't say, no, Billy Bob should not be fired because the economy is doing really bad right now and he's got 3 kids and he just got this job and he had to go through the special training. And no. Just talk about the statistics. What do the numbers say? Next, find the probability that x is at least 1. So this is that type where you would have to do the case where x equals 1, or 2, or 3, or 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then add up all those 14 cases. Or, to simplify life, you could do 1 minus the opposite. And the opposite of at least 1, if you don't have at least 1 of something, you have none of them. And then, just by some strange coincidence, we just did that for part A. So that means it's going to be 1 minus 0.167. 1 minus 0.167. Hey, that's not a decimal. That's a decimal. is 0.833. And then you could say, no, he should not be fired because what's the probability there should be at least one? Well, there is an 83% chance that he should have gotten one positive test, but that's not 100%. If this would have said something close to 100%, I'm 100% sure or 99% sure that he should have gotten one test and he didn't, then I would say something's weird is going on. Okay, notice this. Use either part A or part B. Then back to some probabilities. So two different cards are drawn. Find the probability of getting a king and then an ace. So remember that the and turns to multiplication. So for a king, there are 4 kings, and if that's the first card, there's 52 cards in the deck right now. And turns to multiplication, and then for an ace. Well, since 1 king has been taken out, there's now only 51 cards left. And for the aces, there's 4. So then, this would be 4 times 4 is 16 on the top. On the bottom, I need 52 times 51, and I'm going to put them in parentheses so that they're both in the denominator. So 0.006. So that would be unusual. Next up, find the probability of getting a queen or a red card. So the or turns to addition. The probability of a queen. So there are 52 cards. For queens, there's 4 of them. Since we're only talking about one card, it's either it's a queen or it's red. So when I say one card has been taken out, well, it's either a queen or it's not. If it's not, it's the other possibility is that it's red. So how many red cards? There are half of them. So half would be 26 out of the 52. Then what's the problem? The problem is there are 2 red queens, Queen of Hearts and Queen of Diamonds. They got counted when I counted the queens and when I counted the red cards. So then what I need to do is subtract those 2 red queens, and then we have it. So that would be 30 minus 2, that's 28 out of 52. So that's 0.538. All right, see you soon.